All right, welcome to the second part of classifying 2D figures. The last time we talked a lot about the fact that a 2D shape is also known as a plane figure, P-L-A-N-E, meaning that it is flat, but it does have two dimensions, length and width. And polygons are the shapes that we were thinking about looking at and classifying that live in or under the umbrella of 2D shapes. Polygons, if you remember, have to be made up of straight lines. They have to be closed. And they cannot be things like circles or half circles or have any kind of curves in there. So just as a review, we talked about a lot of different polygons. We talked about three-sided polygons that we call triangles. We talked about quadrilaterals, which are four-sided. We talked about pentagons, which are five-sided, hexagons, which are six-sided, octagons, which are eight-sided. And then we said that quadrilaterals, actually, there are many quadrilaterals that live under the four-sided polygon umbrella. Namely, we talked about rectangles, parallelograms, rhombus, trapezoids, and squares. So just as a review, let's see how we would do with this. Make sure you have your math notebook ready to go. Make sure you have a fresh date and label this video as classifying 2D shapes, video 2. And let's see how we do. So this question here says a rectangle has how many pairs of parallel sides and how many pairs of sides that are of equal length and how many right angles. So three different questions. So let's just think about this one first. This is a rectangle here in the picture. How many pairs of parallel sides? As a review, parallel lines are lines that will never touch each other forever and ever in both directions, no matter how far you go. And so this would be an example of a pair of parallel lines. So let's see how many are in this shape. Here's a line here. I see a line parallel to it here. So there's one set. And then there's one here that goes with this one over here. So there are two pairs of parallel sides here. How many pairs of sides are of equal length? Well, in a rectangle, we learned that opposite sides are the same length. So if this was 4 inches, this one across the street would also be 4 inches. So there's one pair of sides that are the same length. And then, of course, these two as well. So it seems that the pairs of parallel sides are also congruent or of equal length. So there's two pairs of sides that are equal too. And how many right angles? I see one here, one here, one here, and one here. And it makes sense that there are 4 right angles because this is technically a quadrilateral. Rectangles are under the umbrella of quadrilaterals, which we know have 4 sides and 4 angles. Okay, so let's think about rhombus. If you remember, a rhombus was the one, it sort of looks like a square, however, it does not have right angles at all. It does have 4 sides that are of equal length, the way that a square does, and it does have 4 angles, but they are all what we call obtuse angles. They're bigger than 90 degrees, and they are not right angles. So we can't call it a square, but we do still have the parallel happening, and we do still have the equal lengths happening. So a rhombus has how many pairs of parallel sides? 2 pairs, just like a rectangle does. How many sides of equal length? All 4 of them. And how many angles do you see there? There are 4. The only thing is they are not right angles, the way that they are in a rectangle or a square. All right, so that was a good review of most of our quadrilaterals. Let's take a look at this one too. This is a trapezoid. So if you remember, trapezoids are special because they only have 1 pair of parallel sides, and the other sides that are opposite each other will eventually meet up one day when you keep going. They will intersect, so we can't call those parallel. However, this is still a 4-sided shape, so it's still a quadrilateral, and it still has 4 angles. So try this one in your notebook. Press pause, go ahead. All right, we should have said a trapezoid has 1 pair of parallel sides, and still it has 4 angles, 1, 2, 3, 4. And sometimes a trapezoid could have how many right angles? Well, it can't have 4, because if it has 4 right angles, that's going to force. If you think about drawing a figure, here's 1 right angle, here's 2. If I have 2 more right angles, it's going to have to be a rectangle or a square. So to get that trapezoid, we have to have 2 sides go in. So we could have 2 right angles, and we could lengthen the side. That's still a trapezoid right there. And these are right angles. I still have my parallel sides here. I still have 4 angles. It's just that 2 at max can be right. You can't have 4 right angles because then it won't be a trapezoid. It'll be a rectangle. Okay, a parallelogram. This is a parallelogram down here. Remember we saw those last time. Try to answer these questions in your book. Press pause, go ahead. Okay, a parallelogram has 2 pairs of parallel sides, just the way that a rectangle did. There's 1, there's 2. It also has 2 pairs of sides equal length, just like the parallel sides. This one's equal to this one, this one's equal to this one. And then how many angles? 4, because it is a quadrilateral still. Nice job. Okay, press pause. I want you to try to answer these questions true or false. Be really careful, because remember that the entire statement has to be true for the whole statement to be true. If there's even an element of something that's not right, the whole thing's false. Press pause, go ahead. All right, a parallelogram is not a square. Well, if I draw a parallelogram, it definitely doesn't look like a square. However, technically, a square is a parallelogram. So I could say the opposite. Because to be a parallelogram, all you need is 2 pairs of parallel sides, which a square has. So a square is a parallelogram, but a parallelogram will not always be a square. So that's a true statement. Remember, if anything I say confuses you or you need to hear it a second time, remember to press rewind and listen one more time. All right, let's try this one. A square is a special type of rectangle. So if I look at a square, that's not a good square. That looks more like a rectangle. Hold on. If I look at a square, I know that squares have all sides are equal. They also have right angles, and they also have 2 pairs of parallel sides. So technically, to be a rectangle, all you need to be a rectangle are 4 right angles, which a square has, and 2 pairs of parallel sides, 1, 2, which a square also has, and opposite sides congruent. So these are congruent or of equal length, and these are congruent or of equal length. So a square has all the traits that a rectangle has. It just has one additional trait of all equal sides. So a square is a special type of triangle, for sure. All right, a rectangle may or may not be a square. Based on what we talked about here, that is true. A rectangle could be a square because this is technically a rectangle as well. But a rectangle can also look like this, so it could not be a square. And a trapezoid is a parallelogram. That's definitely no way. Because to be a parallelogram, you have to have 2 pairs of parallel sides. And if you remember, trapezoids only have 1 pair of parallel sides. So there's no way a trapezoid can be a parallelogram. Just as a reminder, we looked at this the last time. I just want to remind you, when we're getting really specific, so if you think of like a big circle and all of these are quadrilaterals, okay? Trapezoids have the least amount of rules as to what makes a trapezoid a trapezoid. It just has 4 sides and 4 angles, so it's a quadrilateral. But then you have a bunch of quadrilaterals that are technically all parallelograms. So a rectangle is a parallelogram because, again, you just need opposite sides parallel, which this has. A square is a parallelogram, and so is a rhombus. And that is all that you need to be a parallelogram. A parallelogram, we always use this shape to represent it. but you can get even more specific, and you can technically say that all 4 of these shapes that are in that red circle are parallelograms. But then when you get down here, this gets a little bit more interesting because squares and rectangles both have right angles, but then squares and rhombus both have all sides equal to each other. So there are things that a lot of them have in common, and basically you can call a square any of these things. A square is technically all of these shapes because it can be a rectangle, you can call it a rhombus, you can call it a parallelogram, you can call it a quadrilateral, you can call it all of those things because a square has all the traits that those other things have. Whereas, like a parallelogram will not always have the traits that squares, rectangles, or rhombus have. All right, try these 3 in your notebook. Press pause. Go ahead. All right. A rectangle has 4 right angles? Yes, it does, for sure. A rhombus has 4 equal sides? Absolutely, it does. A parallelogram has only 1 set of parallel sides? That's totally false. You can't be a parallelogram unless you have 2 pairs of opposite sides. All right. Press pause and find how many polygons exist in this figure. Go ahead. All right, so let's count them all. So there's this big one. That would be 1. And then there's, of course, all the little ones. 1, 2, 3, 4. There's 4 more there. So now I'm at 5. We could also technically say that this is 1. There's a parallelogram there. We could also say that, let's say this is 1. That is a 1, 2, 3, 4. That is a pentagon right there. We can also say that this is 1. That's a trapezoid right there. And we could technically say that all of this is 1. We could say that, oops. We could say that, let's see, we have those 3 together. We could also have these 3 together. We could say that all of this is 1. And we could also put all of these together and say that that is 1 as well. So there's actually, there are a lot of different polygons here. I want to talk about this one as a class, so I want you guys to make your best guess. There might be more than what I've just shown there. And we will come together and see how many all the kids found. All right. This is kind of like a review of all of our polygons before we move on and start talking about triangles. So press pause and give this one a try. Go ahead. Okay, a polygon with 4 sides is a what? So a polygon, which is a closed plane figure, that has 4 sides is what? Definitely a quadrilateral, because this one has 3 sides and this one has 6 sides. Okay, a quadrilateral with 4 sides, okay, of equal length and 4 right angles. So we've got 4 sides of equal length, plus they all have right angles. What shape is that? That would be a square. A rhombus doesn't have right angles, and rectangles don't have all equal sides. Okay, which of these shapes is a quadrilateral that has 2 pairs of parallel sides? So 2 pairs of parallel sides, 2 pairs of sides that are equal length, and 4 right angles. That's a lot of different things. Let's see. So I need, well, I've got a rectangle, a square, and a rhombus as choices, and all of those have 2 pairs of parallel sides. So there's that. I also need 2 pairs that are equal length. So they all have 2 pairs that are equal length, but I need also 4 right angles. So this one's going to be out because it has no right angles. And if they wanted me to pick square, they wouldn't have said 2 pairs of sides that are equal length. They would have said all of them are of equal length. So I'm thinking that they're going for a rectangle here. All right, which of these is a quadrilateral with two pairs of sides that are also equal length? So let's see. Definitely not a triangle because I need a quadrilateral. So a parallelogram or a trapezoid. I need two pairs of sides that are equal length. Well, a trapezoid can be drawn in so many ways, and their two pairs of sides will not always have equal length. So they must be talking about a parallelogram, because no matter how you draw a parallelogram, the opposite sides will be congruent or match up. Okay, a parallelogram with all sides of equal length, that would be a rhombus. This one has 5, and this one doesn't have all sides equal. And then which one is a quadrilateral with two sides that are parallel, but they're not necessarily equal length? Let's see. So not a square, because they're all equal length. And not a rhombus, because they're all equal length. So a quadrilateral with two sides that are parallel, but not equal length. They didn't say two sets, they just said two sides. So it must be a trapezoid, because there's 4 sides in a trapezoid, and 2 of them are parallel to each other. But they're not all equal, so they're talking about just those 2 sides right there are parallel. All right, let's move into triangles. So just like quadrilaterals, triangles can also be broken into a lot of different classifications. You can classify triangles either by sides or by their angles, okay? So just like with the quadrilaterals, we've got sides and angles happening. So I want you to please make cards for these the same way that you did for your quadrilaterals. And let's first talk about the equilateral triangle. The equilateral triangle is special because remember we're thinking about sides, not angles. All 3 sides of an equilateral are congruent or the same. And that's a pretty special thing. In the way you pronounce this is isosceles. Go ahead and try to say it. Isosceles. In an isosceles triangle, we have 2 sides that will always have matching length or be congruent. And then this is pronounced scalene. In a scalene triangle, all of the sides are completely different lengths. So there's nothing congruent at all happening here, okay? So make sure you have your 3 cards that say this. And these are the way that we'll classify just based on sides. Remember, we didn't talk about anything with angles yet. So let's talk about angles now. You can also, of course, classify these things by their angles. So that means we're looking in here. We don't really care about the sides. We're thinking about the angles, okay? As a review, you should remember that there are 4 types of angles. There are right angles. When we mark them with a little box, it means that they're 90 degrees. There are acute angles, which I always remember because it has the word cute in it, which are smaller than 90 degrees. There are obtuse angles, which measure larger than 90 degrees. And then there are straight angles, which go straight across, means the whole thing is opened up, which are exactly 180 degrees. So we look for these angles in triangles. As soon as you notice a right angle in a triangle, we just call it a right triangle, no matter what. As soon as you see that thing, it's a right triangle. Now, acute triangles are pretty easy to spot because all 3 of the angles are acute, which makes sense because if you think about it, if you draw an acute angle, if you then connect the 2 endpoints to create a triangle, there's no way to build an obtuse angle. Like, they're all going to be really small if you already have one acute angle happening. So acute triangles have 3 acute angles. Now, an obtuse triangle, you can start building a triangle with one very large angle, one obtuse. As soon as you draw that obtuse angle, the only way to connect the 2 endpoints is by creating 2 acute angles. So just like with the right triangle, as soon as you see the right angle, you know it's a right triangle. As soon as you see one big obtuse angle, you call it an obtuse triangle. So these are ways we can classify by angles of a triangle. Make sure you have your 3 cards for those. You should have 6 altogether. If you need to press pause to study them for a minute, you may. Otherwise, make sure your notebook is ready to go, and let's keep it moving. So this is just a summary of what we just talked about. These are the ways to classify triangles by their sides, and these are the way to classify triangles by their angles. We talked about equilateral. We talked about isosceles. And we talked about scalene. We also talked about acute, which has all those small angles, obtuse, which has that one big angle, and right, which has the one right angle. All right, press pause, try to answer this question. Okay, so if a triangle measures 26 degrees, 41 degrees, and 113 degrees, what I notice is that this is an acute angle, this is an acute angle, and this is an obtuse angle. Remember, as soon as you have one obtuse angle, we can call this triangle obtuse. I can't call this triangle scalene or isosceles or equilateral because I don't have any information about the sides of this triangle. I'm only given information about the angles, which means that I can only classify it by angles because that's all that I've been given information about. Okay, let's try this one. Press pause, go ahead. All right, I'm sure you got this one very quickly. If we know that the thing has a right angle, it is a right triangle, no matter what. All right, let's keep going. Press pause, go ahead and try. All right, a triangle with measures 26, 46, and 108. Just like that one we saw in the beginning, we've got acute, obtuse. As soon as there's one obtuse angle, you say that the whole thing is an obtuse triangle. Nice job. All right, last but not least, what shape would be a triangle with three angles that measure less than 90 degrees? Yes, it would be an acute triangle because that means that all the angles in the triangle are acute, which is what gives us an acute triangle. All right, nice job. You may go and try the activity for classifying 2D shapes.